Now we'll talk about finding the roots of a polynomial using polynomial division. And let me say out of the gate that this is a classroom method that would not be used in the real world. I think it's best to be blunt when stuff like this occurs. I have tried to limit myself during this class to applied mathematics. I've done a lot of word problems. I hope you haven't felt I've been completely wasting your time doing stuff with no applications, but this one section of the textbook, I have to call it as it is. And what it is a toy method that isn't used in the real world. If I had complete control over this class, I might not teach it, but it's in the course description. And when we do assessment, we assess over it. So, it is what it is. Let's just demonstrate this method via an example. Let's find the roots of this fourth degree polynomial. So we have once again plugged the polynomial we're interested into our calculator. And we are, once again, in spite of what I said about doing this using division, going to find a root using our calculator. Let's zoom out. We see 4 roots. And if we look at these roots, it looks like maybe some of them are nice whole numbers. Like it looks like maybe 1 is our root, and maybe -2 is our root. It's a little hard to tell, but oops, didn't mean to do that. It's a little hard to tell, but we can use our 0 command to find this root and verify that it really is just 1. So we start this process by finding a root. And then we do synthetic division. This root into this polynomial. Drop the 1 down, multiply, add, multiply, add, multiply, add, multiply, add. Synthetic division is quite quick once you get a handle on it. And what we're doing here, the point of this is that we're factoring this polynomial. X minus 1 times this which is 1x cubed plus 7x squared plus 12x plus 4, and our remainder is 0. So that's all there is. And now the point of doing this, we're setting this equal to 0, and the so-called zero product property tells us that if a product is equal to 0, one of the terms in the product is equal to 0. This doesn't give us anything useful. We already knew that 1 was our root. But what we're now going to do is we're going to take this third degree polynomial and we're going to set it equal to 0. And we will begin this process anew. Start by taking a look at this. X to the third plus 7x squared plus 12x plus 4. We see 3 roots. This process really only works if you have a nice root. I mean, for example, there's a root here somewhere between 0 and -1. We could find it. Here's a value to the left, a value to the right, a value near it. And we get -0.4384472. Great. But just try to do this synthetic division and see where it gets you. It will almost immediately turn out to be a terrible mistake. Now we add these, we get some ugly decimal, we multiply, we get some horrible decimal. Every single step is going to have to be done with a pocket calculator. There's just no way. So let's look for maybe a better root. Back to our calculator. So here's -1. Kind of looks like -2 might be our root. If it is, we can certainly do synthetic division with -2. And it is a root. this 1e negative 12, 1 times 10th to the negative 12, that is 0. There's just a little rounding error. So let's get back here, and instead of that abominable decimal, let's use -2. The 1 drops down. After that, it's multiplication followed by addition. Multiplication followed by addition. Multiplication followed by addition. Incidentally, this is the second time we've got a remainder of 0. That's not a coincidence. If you get a remainder other than 0, something's gone wrong. And now you just repeat this process. So how did this work, as it were? We started with this polynomial. We found our root. We factored the polynomial. Then we set this polynomial equal to 0. So we found a root on our calculator. We did the division. This polynomial that we're setting equal to 0 can be factored like this. And now we do not go back to our calculator and find another root. So we are setting this polynomial equal to 0, just like we did here, but x squared plus 5x plus 2 equals 0 does not require any fancy division tricks or technological assistance. We can use the quadratic formula here. Negative b plus or minus the square root of b squared minus 4ac times 2 times a. So -5 plus or minus the square root of 17 divided by 2. And we are done now. Once we can use the quadratic formula, the problem's finished. Let's add in the 2 other roots that we found using our calculator. Here are the roots of the polynomial.